Hello and welcome to a new video on IGCSE Physics Classified Paper 4. In this video, we shall be discussing stars. We will begin with basic concepts. The Sun is a star in a galaxy. State the name of the galaxy. So, of course, the galaxy is the Milky Way. Complete the following sentences. The galaxy that includes the solar system is called the Milky Way, and the universe includes billions of galaxies. Of course, you have to know that the solar system is in the Milky Way galaxy, and that there are other galaxies constituting what we call the universe. Next, we move on to light years. Show that 1 light year equals 9.5 times 10 to the power of 15 meters. So how do we solve that? We begin by saying that or by defining what a light year is. So what is a light year? A light year is the distance traveled by light in 1 year. So we have time, which is 1 year, and we have speed of light, which we should know is 3 times 10 to the power of 8 meters per second. So of course, we have to convert the year into seconds. So this is what we do here. 365 to go to days, and then 24 to go to hours, 60 to go to minutes, and then 60 to go to seconds. So we convert 1 year into seconds, and we get this number here, 3,000 or like 3,153,6,000, which would be like 31,536,000 seconds. Next, we figure out how to get the distance from the speed and the time. Of course, this is a very basic formula. Distance equals speed times time. So all we have to do is just multiply the speed by the time, and we carry out the calculation. We get this very big number. And if we want to write this in scientific notation, 3 zeros, 6 zeros, 9 zeros, and 11 zeros. So we have 94608 times 10 to the power of 11. Of course, this is not scientific notation because we want to have a decimal after the 9. So we move 1, 2, 3, 4. So we have to add 4 to this power, and it becomes 9.46 times 10 to the power of 50. 9.46 is approximated, of course, to 9.5 times 10 to the power of 15 meters. Next, we move on to the life cycle of stars. Complete the sentences about the life cycle of stars. Protostars are formed from what? So it begins with interstellar clouds of dust and gas. So you have clouds of dust and gas orbiting in space, and they form what we call protostars. Proto is the same as prototype, for example. What's a prototype? It's like the conceptualization of something, like a model for something. So prototype is like the tested version in a sense. So protostar is kind of the same. It's like the conceptualization of a star. It's the beginning of a star. So you have clouds of dust and gas, and then they form a protostar. And then what happens? So the protostar experiences two forces, a force in the inward direction pointing in, and this is gravitational attraction. But inside the star itself, there is very high temperature. So this creates an outward force. It's pushing it away. So when these two forces balance, the protostar becomes what we call a stable star. So this is how we begin with clouds of dust and gas. These form protostars. And then the protostars become stable stars when we have balanced forces. The inward force of gravity versus the outward force due to high temperature. In C, we are told the initial fuel used to power nuclear reactions in stars is hydrogen. We know that we have nuclear fusion. From the video on the solar system, we know that 2 hydrogen nuclei fuse together to form 1 helium nucleus. So hydrogen is the initial fuel. Stars that are approximately the same size as the sun become red giant stars, which then form what we call a planetary nebula. So you have to know the sequence of stars as well. And at the center of this planetary nebula, we have what we call a white dwarf star. Fill in the gaps about a star much more massive than the sun. So you should know that in the life cycle of stars, we have 3 stages. So we have clouds of dust and gas. And then we said that these form what we call a protostar. And then this protostar becomes what we call a stable star. Now, the stable star can evolve into 2 different things depending on the size of the star. So if it's the same size as the sun, it follows a certain pattern here. If it's much larger than the sun, it follows a different pattern. So let's check together what happens when it's much larger than the sun. So the stage that follows the stable state in the life cycle, so we said that after stable star, we diverge, we have 2 different paths. And for the large one, what do we get? We get a red supergiant, which then explodes into a supernova. So supergiant explodes into a supernova, and this forms a nebula, which leaves behind a neutron star or a black hole. If you remember in the previous question, for the medium-sized stars, we said that we have also a planetary nebula here, and it has a white dwarf. However, for the big-sized stars, we also have a nebula, but in the middle, instead of the white dwarf, we have a neutron star or a black hole. So this is the difference between a medium-sized star and a large-sized star. Describe and explain how a stable star is formed. We already gave an idea about this when we talked about the balance of forces. Inward is gravity, outward is due to temperature. So let's write this more clearly. Hydrogen atoms in the nebula are pulled together by gravity. The temperature of hydrogen increases and a protostar is formed. Nuclear fusion begins, and the outward resultant force, and we said that this is due to temperature, balances the inward force, and we said that this is due to gravity. So when the force due to temperature balances the force due to gravity, we get a stable star. There are stars in the universe with masses much greater than the mass of the sun. Describe what happens to these high mass stars when they leave the main sequence stage. So the main sequence is up until when we have the stable star. We said we have clouds of dust and gas. This is followed by protostar, which is followed by stable star. This is what we call the main sequence because this happens regardless of the size of the star. After stable star, we have 2 different paths. For medium, like the sun, and for large stars that are much larger than the sun. So what happens when you have a large star? Large star, we get a red supergiant. And this explodes into a supernova. So everything has the word super because it's a very large star to begin with. So let's check the answer together. The star becomes a red supergiant, then it turns into a supernova, forming a planetary nebula, which leaves behind a neutron star or a black hole. So these are the 3 statements that you needed to write for this question. Describe the stages in the evolution of a star similar in mass to the sun. So in this case, we're going to go with the left path. Again, we have clouds of dust and gas, followed by protostar, followed by stable star. This is the main sequence stage. And then for a similar sized star to the sun, we move in this direction, and you don't have a red supergiant, you just have a red giant. So let's discuss what happens after red giant. Like we said, we have clouds of dust and gas, and we form a protostar. And then this becomes main sequence, which is what we call a stable star. Main sequence and stable star are the same thing. Then we're going to go in the path of the medium star. So it becomes a red giant, not a red supergiant, just a red giant. And then the red giant becomes a white dwarf, followed by a black dwarf. For the final question in this video, we are required to use words from the box in order to fill in the blanks. So let's begin. This is the evolution of a star with a mass much larger than the sun. So we're going in the direction of supergiant and so on. So hydrogen atoms in a nebula move towards each other. This is the force of gravity we talked about. And because they move towards each other, their kinetic energy increases, which increases the temperature. So we said that as they move towards each other, their temperature increases. And you should know that temperature is the average kinetic energy of a body. So let's write this down because it's important. Temperature equals average kinetic energy. So since we know that the temperature will increase, we must also figure out that this is because their kinetic energy increased. Now, when the temperature is high enough, nuclear fusion of hydrogen will start, and stars enter the stable state, or what we call the main sequence stage of evolution. This is where it becomes a stable star, and we said that stable stars are characterized by a certain equation, Fn equals F out, and we said that Fn is due to gravity, and F out is due to high temperature. When hydrogen fusion stops in the core of the star will start to contract. This increases the temperature in a layer surrounding the core, and hydrogen fusion restarts in a layer surrounding the core as well. This causes the star to expand, and the surface temperature decreases. The star is now a red supergiant. Eventually, nuclear fusion stops in the core, and the star explodes as a supernova, leaving behind a neutron star or a black hole. So you should be aware of this process. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.